Hey you guys, this is Mr. Sal. This is the practice test review. I apologize, I'm still a little sick, so I won't be able to be in class, but this video will help you with the entire review. The test will still be next time, since this is just a review and we're giving you the answers here. Also, next time the practice test will be due as well. So we start with number 4. Rectangular hat box has a volume of 5,184 cubic inches. The box is 2 feet long by 18 inches wide. What is the hat box's height? So we just need to remember that the volume is length times width times height. And we can replace the values that we have. The volume is 5,184. The length is 2 feet there. Now we need to be careful at this point because it says that the length is 2 feet long, but we need to remember that so far we're comparing everything in inches, so we need to change that 2 feet into inches. And 1 foot is 12 inches, so 2 feet would be 24 inches. So we need to replace the length there with 24 inches. Then we can see that the width is 18 inches. And this gives us the equation as we have it. We'll do 24 times 18. So then I got 5,184 equals 432H. Then we'll divide both sides by 432. That gives me 1H. And after putting that in my calculator, 5184 divided by 432, I got 12. Now we need to remember to label this, especially on the test. This is in inches, so it looks like the height is 12 inches. Alright, next up here, what is the volume of the right triangular prism? So what that means is that this triangle right here in the face, this face, is a right triangle. So we need to remember as well that all triangular prisms are just half of a rectangular prism. So we could finish off that, and we can see that the purple one on top of the red one is a full rectangular prism. However, this one is only half of that. So it's like finding the volume of a box, but we're going to cut it in half. So if this were a full box, then the volume would be the same as the length times the width times the height. And then, since this is a triangular prism, we'll divide that by 2. So now we can just replace the length, the width, and the height with the values that we have. And it doesn't matter which one of these you use as length, width, or height, because no matter how we arrange these values, when we multiply, we're going to get the same value anyways. So let's do the numerator. 4 times 8 times 12. And that gives me 384. I'm going to divide that by 2, which would be my actual volume here. And I got 192. Of course, that's in meters cubed. So the volume of this right triangular prism is 192 cubic meters. Now, it may be helpful to remember that the reason we were able to do this so directly is because of this right angle right here. If it were more of a parallelogram, we'd need to find the height of that triangle, or they would have to give it to us. So when that happens, they're going to give us a lot more values, and we have to figure out which ones are actually important. For example, if they told us that this length right here is 9 meters, or about 9 meters, that value is not important to us because it's the diagonal across the box, right? If we had drawn this way, like we did before. See, that 9 meters is the diagonal through that box. We don't really care about that value because it's not length, width, or height. It's a diagonal value, so we have to be careful in the future with that. What is the volume of this square pyramid? Again, this one did not give us any unnecessary values. We do have a square there at the bottom, which we'll need to find the area of that. But once again, if we treat this pyramid as we would a rectangular prism, something like this, so the volume of that box right there in red, which is a full box, is length times width times height. However, since this is a pyramid, we would be dividing this by 3, because a pyramid is just a third of a regular box like that. So now we can go in and replace the length, the width, and we're going to say the height in this one specifically is the 8. So the length and width are 6. And this is what we have. So 6 times 6 times 8, that's going to give me 288. And I will need to divide that by 3 to find the volume of the actual prism. The square pyramid. So that means the box itself had a volume of 288 cubic inches. But now that we're looking at just the pyramid, we have the volume at 96 cubic inches. And that is the volume of this square pyramid. Here we have the surface area of a square pyramid, not the volume. So we have to be careful. Make sure that we're paying attention to what exactly it's looking for here, and that's surface area. So we need to acknowledge here that we have 4 triangles and a square. Alright, so here are my 4 triangles. Now it's shown the height here along this line. And that height there is 12 feet. We're going to need that value. And the base for all of these triangles is this 19 feet right here. So if we find one of these, the area of one of these triangles, then we should be in pretty good shape. Now the area of one triangle is going to be the base, which is 19, multiplied by the height of the triangle. And then we're going to have to divide that by 2 because all triangles are just half of a parallelogram. And again, this is just the area for one of the triangles. 19 times 12 is 228. And then dividing by 2 gives us 114 square feet. So that means the area of this one also is 114 square feet. And same with these other two. Again, that's because they have the same dimensions. So let's list those here on the right. And the last one that we're going to need is the area of this rectangle. Well, this is a 19 foot by 19 foot square. So the area of the square will be 19 times 19, which is 361 square feet. So I'm going to take those 114s and add another 361. This will tell me the full surface area of all 5 faces or surfaces of this pyramid. And we can see that we have 5 faces. 1, 2, 3, 4, 5. Just to acknowledge that there are 5. Because some of you guys did 4 times 114, and that's okay. As long as we remember we have 5 faces. But let's go ahead and add these together. And I got 817 square feet as the surface area of this square pyramid. Alright, and there's 6 again, so if you guys needed, you can check your work and your answers. Alright, what is the surface area of the cube? And here's the nice thing about cubes, is each of the surfaces or faces of the cube are the same. They are squares, and each of them, as we can see, even on this face, right, is 11 by 11. We could put 11 centimeters there just to show that this square has an area of 11 by 11. So we can look at that. The area of that front face is 11 times 11, which is the same as 121 square centimeters. Well, how many faces do we have? Well, we got the front one, we got the top one, we got this one on the side, we got the one in the back, we have the one on the left, and then of course the one on the bottom. So if we counted all those, we counted 6 hopefully. So I'm just going to say that I've got 6 groups of this 121, which will tell me the whole surface area of this cube. Now this is the nice thing about cubes, is that we don't have to find the dimensions of each face. So this is usually only what we would do with a cube. So when I multiply those, I get 726 square centimeters, and that would be the surface area of this cube. Alright, hopefully you guys had enough time to get that finished. What I'm going to actually do on this one is break this up so that I have 2 boxes, and we can kind of see how it's been broken up. I've got this shape right here, this rectangular prism, which I can pull out and just draw separately. So I'm going to ignore the other piece just for now. It's going to be important to remember on this shape that the rear part of this is connected to the box in the back right here. Okay. What this means is that's not a surface area that I need to include with the surface area of the entire figure. So on this shape, I'm only going to have 5 faces. And first I'm going to identify this front face. Here, now usually it would match in the back there, right? So I'm going to redraw it here. There's a 9 foot by 1 foot rectangle. And of the small box, I'm just going to put my measurements over here. So I got 9 square feet in this small rectangle. Now I'm going to look at the rectangle on the right here, which is a 3 by 1 foot rectangle. And its area would be 3 times 1, which is 3 square feet there. So I'm going to tack that on, add it. But that would also match this length, or this surface on the left. So I'm going to add another 3. Next up, I have the top of this portion of this rectangular prism, which is a 9 foot by 3 foot rectangle. So if I want the area of this thing, I'm going to take 9 and multiply it by 3, which would give me 27 square feet. Now that's just the top. I also need to match it with the bottom here. So I'm tacking on another 27. All these numbers here in the top left, I'm going to add those, and that will give me the surface area of just this portion of the box. So that's something you can do in your calculator. And that's going to give you 69 square feet. But now we got this other box, this other portion of this figure, that we also need to find the surface areas of. And we'll find the volume after we find the surface areas of both. So we're just going to do this one at a time so we don't get stuff mixed up. So just to identify, we're just looking at this box right here. And I'm coloring in that portion which is connected to the other box because it's not part of the surface area. So I move that down here, and I've got my measurements, 9 by 4 by 2, but again I'm taking away that portion of the front face. So I'm going to start with, it doesn't matter where I start, I guess. I'm going to start with the top portion right here in red. And that's going to give me a 9 by 2 rectangle. So if I want the area of this thing, I'm going to do 9 times 2, which is 18 square feet. So I'm going to add those up here at the top. Of course, I've got the bottom portion of this thing as well, which will be included as another 18 because it matches the top. Next, I'm going to look to the right side right here in purple, and that gives me a 2 foot by 4 foot rectangle, which has an area of 8 feet squared. So I've got another 8 feet squared. Of course, that will match this portion on the left as well. So I need to add another 8 square feet. Now I'm going to look to this front portion right here. Alright, that rectangle is a little bit smaller. It's 9, but it's not 4 feet tall, right? We can see from back here that this height right there is 1 foot. So this length right here is 3 feet. So it's a 9 by 3 rectangle, which we've already figured out, but I can still show it here. The area is 9 times 3, which would give us 27 square feet. So I'm adding 27 square feet into this. That's not going to match that back portion of the box because we had to cut out that small piece, right? So I'm going to be looking over here for that. This now is a 9 foot by 4 foot rectangle. If I want the area, I just multiply those. Length times width, 9 times 4, 36 square feet, which I will also add into my total. So for this box, I have my total surface area at 115 square feet. So for the full surface area, I'm going to take the 115 and the 69 from over here. That'll give me the full surface area of the entire figure. And it looks like it's 184 square feet. Surface area is actually a little bit more involved than the volume is because we're looking at sides that are, or surfaces that are included and not included with the shape. With the volume, we just need to break the shape up into 2 shapes as I've done already right here. So to start off, I'm going to be looking at this box right here, which would have a volume of 9 length times width times the height, and that gives me 27. Now we need to remember with volume, this is 3-dimensional, so this is not feet squared, it's feet cubed. Next I'm going to look at the bigger box right here. Now we don't necessarily worry about the 1 there because with volume it can include sides that or surfaces that are open, kind of like an open box. Whether it's open or not, it still fits a certain volume. So the volume of this one is, we got the length 9 times the width, which is 2, and the height is 4, which is 72 cubic feet. Now what I will do is add these two together, which will give me the full volume. And now we have the volume at 99 cubic feet. The volume of a triangular pyramid, this is pretty important for you guys to remember. We can remember how to find the formula, even though we may know it, whether it's from our notes or we just know it. So hopefully you guys remember, we start with a rectangular prism, which has a volume of length times width times height. But after we take this thing to make a triangle, we just cut this thing in half. And that takes away this top portion. Well, what did we do to the volume? The same thing we did to the shape. We cut it in half, like this. And that gave us a triangular prism. But we don't want a prism, as we can see, we want a pyramid. So all we do is make a dot in the center, and we connect it to these other 2 points like this. So to clean this up a little bit, and bam, I got my triangular pyramid right here. But what did I do? Well, the pyramid is, because right now I just have this volume right here. That is the volume of a triangular prism. This is a pyramid, so we Hopefully you guys remember that we divided that by 3. A pyramid is like a cone. It's a third of a cylinder, which we may or may not know doesn't really matter. It's just a third. So using this formula, right, we got length times width times height divided by 2, and this divided by 3. What I'm going to do is identify that that's a 90-degree angle right here. So I can say that my length is 4, and I replace my length with 4. Next I can say my width is 8, so I can replace my width with 8. And the height is the distance from the center here to the tip of the pyramid, which we can see is 14. And all I've got to do is plug this into a calculator. So if I work through it, I can find the numerator there, and then I'll just divide that by 2 and divide that by 3. And 4 times 8 times 14 is 448. So that would be the volume of this if it were a rectangular prism. Now if I divide that by 2, I get 224, which would be the volume of the triangular prism. But then we got to divide that by 3, which would be the final volume, which gives me 74.6 repeating. And since this is volume, we're looking at meters cubed. But this told me to round to the nearest tenth, which I will do now. 74.6 repeating, so I'm going to round the 6 up to a 7 in meters cubed. And that right there is my final answer. Number 11 here is more of a review. What is the best approximation for the area of a semicircle with a diameter of 11.8 feet? So just looking back to, this should have been from Unit 7. The area of a circle is where we take the radius, multiplied by the radius, then we multiply it by pi. For this example, I'm actually going to use the button pi instead of 3.14, so we may get slightly different answers. What they gave us, though, was the diameter of 11.8 feet. So my diameter is 11.8 feet. To find the radius, I'm just going to divide these by 2, which will give me the radius at 5.9 feet. So I go into this formula, I replace the radii with 5.9, and this would give me the area of a full circle. What we have up here, though, is a semicircle. So when I find that area, I'm going to need to divide it by 2. A semicircle is half of a circle. So the actual volume of this, the actual area of this thing, plugging this into my calculator, gives me this, 54.679. I'm going to round this to 54. I'll just round it to the 10th, 54.7. And that was in feet, so that will be feet squared. That is my answer. Alright, so looking at this shape, you may think that there's not enough information to figure out what it is. And yeah, we could find the area of this rectangle pretty easily by taking 14 and multiplying it by 32, which would give us 448 centimeters squared. But now we got to figure out the area of this half circle or semicircle. Now what that means is we're going to have to take the radius, multiply it by the radius, and then pi, and then divide that by 2. Well, what is the radius? Well, that's the center of the circle, and then to the outside would be half of the 32, which is 16 centimeters. So I can replace those radii with 16. And this says to round to the nearest tenth, so I'm going to make that 402.1. So now we have the area of both the semicircle and the rectangle. I just need to add those two together now. And what do we get when we add those up? I got 850.1 centimeters squared. So that right there would be my answer for the area of this figure. Alright, this is part 2, so we need to, don't worry about writing the letter. We're just going to find the circumference of these two circles, and we will round to the nearest tenth. You can use 3.14 or pi, it's not going to matter. I am going to use pi, so if your answers are a little off, that would be why. So it's going to be helpful to remember that the circumference is the diameter times pi. And this one gave us the radius of 9 millimeters, so the diameter would be 18 millimeters. So I'm just going to go in and replace my diameter with 18 and then multiply this out. And I got 56.5 millimeters. This is just circumference, so it's just straight millimeters right there. Alright, so number 2 is going to work the same way. They did give us the diameter, so we have the circumference equals the diameter, 4.2, multiplied by pi. So in my calculator, when I multiply those two, it gave me 13.19 and some change, so I'm going to round to 13.2 centimeters. Alright, these next two, we need to find the area of the two circles, and we'll round to the nearest tenth. Again, I'm going to be using pi on these. So for this one right here, I've got a radius of 4 yards. So my area is radius times pi. Now I'm going to go ahead and replace those radii with 4 because I do know what the radius is. So again, this is something I would plug directly into my calculator. And this is area, so it's going to be in yards squared. So my calculator gives me 50.265 and some change. I'm going to round that up to 50.3, and that would be my answer right there. So we'll do the same thing on this one, except for it gave us the diameter of 10 feet, so the radius here would be half of that at 5 feet. And we do need the radius because the area is the radius times pi. And I'm just going to replace the two radii with that 5 value we discovered there. So I'm going to go ahead and multiply this out on my calculator to find the area. And this will be feet squared. So I got 78.5398. I'm going to round that to 78.5. And that would be the area of this circle. Number 5. What is the volume of this rectangular prism? Since this one is just simply a rectangular prism, all we're going to do is take the length, multiply it by the width, and multiply that by the height. Now this is volume, so it'll be units cubed. But let's identify, I'm going to say that the length is 9. So I'll replace my length with 9. Next up, I'm going to say that the 4 is the width. So I'm going to replace the width with 4 rather. And then I've got a height here, which I'm going to say is 2. And I'm going to replace my height with 2. This is something I can put directly into the calculator. 9 times 4 times 2, and I get 72. Now we can't forget to label this. That's going to be in meters cubed. Volume is 3-dimensional, so that right there is my answer. Alright, number 6. A cube has a 5-inch edges. what is the volume. So, I mean, we could draw this out if we wanted to. Alright, there we go. We'll say that's a cube with 5-inch edges like this. So this is just a rectangular prism. It just happens to be that all the rectangles are squares. So the volume of this thing is still going to be length times width times height, but all of these have the same value, 5. Now whatever we get in this, we're going to be labeling with inches cubed, because volume is 3-dimensional, and 5 times 5 times 5 is 125. So the volume of this would be 125 inches cubed. For these next couple problems, we're going to be finding the volume of each of these, and we'll round to the nearest tenth if necessary. So go ahead and make an attempt at number 7, since this is a review. You guys should be able to do this, so I'm going to give you guys a couple minutes to try this one out. Alright, so we're going to treat this exactly like it were a rectangular prism, meaning we'd be finding the volume by taking the length, multiplying it by the width and the height. But since this one is a pyramid, all that means is that it's really a third of all of that stuff. So we're just going to divide by 3 in the end. So let's go ahead and replace our length, width, and height with the values we have. So I've got my length at 10, the width at 10, and the height at 8. So let's go ahead and simplify that one first, just the numerator. 10 times 10 times 8 would give us 800 divided by 3. So I'm just going to plug that into the calculator and round that to the nearest tenth. And that gives me 266.7 inches cubed, which is, again, we need to remember to label this thing in inches cubed. Alright, now that we've got that, go ahead and take a moment, again, a couple minutes, and try this one out. This one is a triangular pyramid instead of rectangular, so you will need to find the area of that triangle there in the bottom. Alright, let's go ahead and get started on this one. Hopefully you guys found your answer. But we're going to do this one together, so at the end just check your answer, and while we go through it, check your work so that you can make sure that you're doing it right. So we got the volume of this thing, and to start off, we should find the area of this triangle here at the bottom there in purple. Now that's a right triangle. That's nice because it gave us the height of it, which is 12, and then the base value, which makes up that 90-degree angle also, which is 9. So we need those two values. As it turns out, the 15 isn't really important in any of this stuff, except to make sure that you know how to find the base and height of a triangle. So keep that in mind. Now what we could do is we could treat this as a rectangular prism, but I'm going to talk about that at the end. So let's find the area of that triangle right there. So that'd be 9 base times the height, we'll say, is 12. And that we're going to need to divide by 2. Now once we get that answer, we're going to multiply that by the height, which we can see is 16. Like this. Now to solve this problem, I'm just going to plug all of this directly into my calculator. 9 times 12 divided by 2 times 16. Now that would have given us the prism for this. I apologize. I would need to divide all of that by 3, not 2, 3. There we go. So once I've divided that by 3, then I would have the actual volume of this. Now that may be a little confusing, but it's going part by part to see what the actual volume of this. So we need to be able to understand all of that stuff. So let's go ahead and plug this into the calculator and see what we get. Alright, so I got 288 meters cubed like this. Now if you didn't like the way that was explained, that's alright. Let's go ahead and go back to this and retry it. You could just use the formula for this, but it's important to know how to get the formula just in case we forget it. Alright, so I'm effectively starting this over. So if you didn't do it that way, then hopefully you did it this way instead. So the volume of any rectangular prism would be length times width times height. Now for this one, we do need to identify that we can look at these two parts, which are the base and the height. See, because what would happen is we would make this a rectangular base right here. And one other thing about this is we've already discussed this, so this is just review hopefully for you guys. Now notice the triangle is half of that. That's why we divided all of that by 2, at least the base part of that, right? Let's go ahead and show what this would look like as a rectangular prism. Alright, so this would be the rectangular prism with the pyramid touching the center of the top portion right here. Essentially, alright. So, but it's been cut in half, right? So we cut this portion off, which means that these parts actually aren't even there, right? Alright, now again, hopefully this helps us see exactly what's going on here a little bit better. So I have now a triangular prism just by cutting our rectangular prism in half. But this is a cone, so that's why in the end we also need to divide this by 3. So just by plugging in the values, we've got a base or length of 9, a width of 12, and then the height right here from the center of that pyramid to the top is 16. So again, this is essentially the same thing that we had, which you could then put into the calculator, just rounding that to the nearest tenths if it's necessary. But again, the answer is going to be the same either way. 288 meters cubed is the answer we wanted. Alright, let's go ahead and find the surface area on this one. Now we got to be careful because we need to be able to identify how many faces there are on this thing. Now if I ignore the triangular or the rectangular pyramid at the top there, I have this box here on the bottom, but the top is covered by the pyramid. So I'm not going to include that surface in the surface area. So that would give me 1, 2, 3, 4, 5. There's 5 faces just from the rectangular prism there at the bottom of the box. And then on the top, again, the pyramid is set on top, so this rectangle right here is not actually part of the surface. So how many surfaces do I have? 1, 2, 3, 4, giving me a total of 9 surfaces. Now this should help us because I'm going to find the surface area of each surface and make sure that I have 9 in the end before I start adding any of these together. Now it may be easier to start the box. The choice is yours though. I'm going to start with this front face right here. Now the area of that front face is also matching the area of this rear face right here. So the length of that is 14 times the width or the height, 8.9, and that will give me the area of one of those. And I got 124.6 inches squared. Now that rear face also matches it, so I'm going to double it up right here, and that shows me 2 of the faces. Next up, I'm going to look here on the right, which matches the one here on the left, and the area of that one appears to be a 14 by 8.9. So that bottom piece is a square, and that's good because we've already found 14 times 8.9, 124.6 inches squared. Well, that leads me to the base piece here, which is simply a 14 by 14 rectangle, a square, and it appears that I get a 196 inch squared square. Next up, we have these triangles here at the top, so let's just focus on this one. As it turns out, since the base of the box is a square, all these triangles have the same area. So whatever I get out of the area of this one is going to be the area of all 4 of them. So the area of that triangle, the base on that is 14 because it's going to match this value. Then we'll multiply that by 13 and we're going to divide it by 2 because it's a triangle, which is half of a parallelogram. Alright, and that gives me 91 inches squared. Now there's 4 of those triangles there though, so let's go ahead and add those in, all 4 of them. I have 1 and there's 4. So I'm just going to go through and count and make sure I have 9 surfaces. 1, 2, 3, 4, 5, 6, 7, 8, 9 surfaces that I'm adding together. That's great. And I know my answer is going to be in inches squared. Let's go ahead and add these together. And I got 1,058.4 inches squared as my final answer after adding all of those surfaces together. Let's find the area of this composite figure. Now, the nice thing about this is we do have a parallelogram here at the top, but then at the bottom, this is a parallelogram which specifically is a rectangle, because rectangles are parallelograms. But I can change this parallelogram into a rectangle, and that's the nice thing about parallelograms is I can take this triangle and move it here, which would give me just one full rectangle if I combine the two. So let's go ahead and do that. I'm going to take this triangle here and move it right here. Alright, so there's that. Just taking that piece off, right? So now I've got this large rectangle, and if I can just find the dimensions of the length and width, then we're pretty good. Now this length here is 12. So the area of this thing, length is 12 times the height or the width. So it was 6 here. and then 4, making the whole side worth 10 centimeters. So I've got 12 times 10, which would give me 120 centimeters squared as the area. Now we have to be careful, because if we did not cut off that piece, some of you don't know how to find the area of a parallelogram, which is fine. In that case, you'd need to find the area of a trapezoid, which would have been the same as cutting off this triangle. You'd need the area of this trapezoid, this rectangle, and this triangle, which may be kind of a pain, so we'll just keep it like it is. All right, number 13, our final question. Hope you guys have understood this right. This is for the practice test, so anything you haven't understood, you need to take home and study. You can watch this video. It is on YouTube. So study everything that you need to so that when the test time comes next time, you know that you're going to do well on it, okay? Now, if you've gotten all these right, you've done excellent. Then the test, as you guys know, should look almost exactly like this. So be aware of that, and that is meant to help you guys out. So hopefully you guys feel comfortable taking the test when that time comes. All right, so let's go ahead and get started on this problem. Now I've got 4 of these triangles, which all are the same because this is a square-based pyramid. So I just need to figure out one of the triangles right here, and then I'm just going to say that I've got 4 of them. So the area of that triangle, the base here is 10, the height is 4, so I've got 10 times 4, but it's half of a parallelogram, so I'm going to divide that by 2. 10 times 4 divided by 2 is 20 inches squared, and we have 4 of those, right? Next up, I've just got this square base here in the bottom. Its area would be 10 times 10, which is 100 inches squared. So from this 4 times 20, I'm going to have to add my 5th face, which is 100. 4 times 20, by the way, is 80. So I really have 80 plus 100, which would give me 180 inches squared. That is my final answer right there. All right, well, that concludes the video. So again, make sure you study the practice test. Make sure you know how to solve all these. Finding the areas of irregular shapes, the surface area of 3-dimensional shapes, and volume as well. All right, you guys. Again, sorry I'm sick. You guys have a good weekend, and we will see you next time.